Welcome one and all to the video on the double Ingles formulas, where you will learn to use the double Ingles identities to make algebraic substitutions in order to simplify and verify trig functions. Here's a review slide on the Pythagorean theorem, where you have a squared plus b squared equals c squared, where given two sides of the right triangle, you can find the third missing side. Here's a review on the sine, cosine, tangent functions, where we will focus primarily on the keywords of opposite, adjacency, and hypotenuse. This slide is the main meat of this video, which is the double Ingles formulas themselves. Here you have three different versions, but we are only focused on sine and cosine. Cosine 2a has two different versions depending on what you're given beforehand. So if you're given cosine, you use the one in blue. Given sine a, you can use the green one. The main premise of these formulas is that given a angle that you may or may not know, if you were to double it, can you still find the value for it? Because it's more than just doubling the value of a function that you are given. So here are the three formulas, and we are going to dive right into practicing using the formulas. So here's our first example. You have sine theta equals 12 over 13. Find cosine 2 theta. So first step is to identify the formula for cosine 2 theta, which is 1 minus 2 sine squared theta. If you are not familiar with a trig function being squared, it's not as bad as you think, because all you have to do is first focus on the sine theta you're given from the original problem. What you do is you replace the sine theta with 12 over 13, but the big thing is the squared function now just applies to the fraction that you substituted in its place. So now it's 1 minus 2 times the fraction of 12 over 13 being squared. Now what you do is you just square the fraction, so 144 over 169, because that's the same as 12 squared over 13 squared. 12 times 12 is 144, 13 times 13 is 169. Next order of operations is to multiply, so the 2 multiplies with the fraction, where you just multiply 2 with 144. That gives you 288 over 169. The denominator still stays the same. The big thing is, how do I subtract 1 from a fraction? Well, 1 is really convenient because 1 can be converted into a fraction very, very easily. Because all you need to do is convert it to a fraction that has the same denominator as the fraction that's being added or subtracted with it, but the numerator itself is the same value as the denominator, because anything divided by itself is 1. So once you have this step, now you just subtract the fractions together. So 169 minus 288 gives you negative 119. The denominator itself is still 169, and that is our final answer because it is not reducible. Here is our second example. So just to give you piece by piece, let's block this off. Apologies. First thing is to identify the formula. Cosine 2 theta is equal to 2 cosine squared theta minus 1. We're using this formula because we're given cosine this time, not sine. Just like before though, you replace the trig function itself with the fraction you're given, but just make sure that you're squaring that fraction itself because the trig function itself was being squared. So now you apply the order of operations, you apply power to the fraction itself, so 8 squared over 17 squared gives you 2 times the fraction 64 over 289. Multiply these two values together and you get 128 over 289, all subtracted by 1. So just to reiterate, cosine function is being replaced by the fraction given. We go through the steps in the order of operations. We convert the 1 into its fraction form of 289 over 289, because what that does, it allows us to subtract it from 128 over 289. And here's another fraction with a negative value of negative 161 over 289. And that is our answer to this problem. So all in all, not too bad. Here's our last example where you have sine 2 theta. Now sine 2 theta is equal to the formula of 2 sine theta cosine theta. So this is different because you have to have two trig function values given to you to find the value of 2 times the theta in the original problem. But we're only given sine theta. So in order to find the answer to this problem, what we need to take note of is, given sine theta, we can actually find cosine theta, and we have to. There's no other way. So in order to solve this problem, what we do is we set up a right triangle, okay? We take note of the fact that sine theta is equal to 20 over 53, which is opposite over hypotenuse. So if I set up my right triangle and I label this angle as theta right here, opposite from it is 28, and the hypotenuse is the longest side opposite from the 90 degree angle, which gives us 53. We apply the Pythagorean theorem to find the missing side, which I did over here in green. If you want to see the full steps, see other videos from previous weeks, such as the angle sum difference videos. B comes out to be 45, so that's our adjacent side, and that's what we need to find cosine theta, because cosine theta is adjacent over hypotenuse. And that's how we get our cosine function. So once you have that fraction for the cosine theta set up, now what we do is we have both trig functions for sine theta and cosine theta for this problem, and now we just substitute it into our formula. So the 28 over 53 takes the place of sine theta, and the cosine theta 45 over 53 replaces the cosine function in that. So 2 times 28 over 53 times 45 over 53 gives us the final answer of 25, 20 over 28 over 9. Again, if you have a number multiplied with the fraction, just multiply it with the numbers on top. So 2 times 28 times 45 gives us 2520, and 53 times 53 just gives us 28 over 9. And that is the answer to this problem. So keep in mind that with the sine 2 theta, you have to use this formula, and you will have to use the Pythagorean theorem and right triangles to find the other trig function that you're missing. But once you have that part set up, you just substitute it in, calculate it all, and you are done.